There we go. All right, check this out. We go buy this house, right? We somehow came to the table, we had cash, now we have the house, we're paying about $2,000 a month. The first month we make a payment, it's about $2,000, right? $377 of that $2,000 goes to the house. $1,449, about $1,500 of it goes to the bank to make profit, their profit. And every month, these numbers change. Like this gets a little bit higher and that gets a little bit lower. So what's happening is at the beginning of the loan, you're barely even chipping away at the loan. You're paying the bank for their money. So they make a lot of their money up front in those first few years, first 10 years. Does that kind of make sense to you? Like it's not even. It's not like half of it goes to the bank, half of it goes to the house. And what happens is you keep going. Let me just scroll down. This is just the first year. Let's go to 2036. Look at that, 2036, 2023. So this is 13 years later, right? Look at your payment. Still, a lot of it's going to the interest, right? And it doesn't start really becoming good for you until, I don't know, towards the end of the loan, 2049. Now look, finally, 2049, right? Now a lot of your payments going towards the house and a lot of the small amounts going to the bank. They've already made most of their money off of you. So, what's that?
She said, so they're not living in a box.
Yeah, so go live. So look, this is kind of showing you. This is a great graph if you can understand it. The blue shows you. This is 30 years. The blue shows you how much you owe on the house. So in the beginning, you owe the full amount, and as time goes on, it drops, right? So it drops like this. The green is the interest that you pay. So you can see you're paying a lot of interest, and at the end, you pay the full amount of interest, right? The principal paid, I don't want to talk about it anymore. Yes, you get the idea? I know this makes people not want to buy a house, but you never want to buy a house and then move out 2 years later. Because basically you've just given a bunch of money to a bank and you haven't paid much of your house off. You still owe a lot of money on your house. That'd be like going and buying a car, paying all those fees, and then a month later going and selling it. You're losing all that fee stuff. All right, so I want to show you something else. This will be kind of like the last thing. During COVID, right, interest rates went way down, historically low interest rates. And so a lot of people refinanced their houses. They went to the bank and said, hey, when I originally bought my house, it was like 5%. So I'm going to put this in here because I don't care about sharing this with you all. When my wife and I bought our last house, it was about $500,000, okay? It's $500,000. We bought it for 30 years, and when we did it, it was about, at the interest rates at the time were still pretty high. They were about, I want to say they were about 3.8, okay? So that's about where we were when we bought our house, all right? 30 years, 3.8, 500,000. And if you look at our schedule, every month, our first months of payments were $746 was going to pay down the house, and that's how much we were paying for interest, right, to the bank. And that's where we were. And the interest rate we had, 3.8, was the best we could get because we both have good credit. So that was like the best that anyone could get. Yes?
Was this after the
It's before, before what?
Oh,
after.
2008. When
this was after 2008.
Oh, okay.
This was after 2008. Okay, so that's where we were, and we were making payments, and then COVID hit, and interest rates went down. And so what we did, notice the payment here, right? It's about $2,300. The interest rates plummeted, and so we refinanced our house, and instead of doing a 20-year loan, we switched it to 15, and we got an interest rate of 1.9%, which is like historic low, right? Never been that low. You know what? Hold on. I'm trying to remember. I think it might have been 20 years. I don't remember. I think it's 20 because the payment stayed almost the same. Do y'all see that our payment is almost the same? It's a little bit more expensive, right? Our interest rate's lower, right? We're only paying for 20 years, not 30. So we saved ourselves a lot of time. But the most important thing is the schedule. I want you to look at the payments. Look at our payments. That's towards the house, that's to the bank. Everything reversed, right? Instead of most of our money going to the bank and a little bit of it going to the house, everything flipped places. So now what we're doing is we're chipping away at our loan faster. And the bank's making their money, but not as much money, right? Like here, they're only going to make how much off of us? $100,000. That's how much they'll make off of us after 20 years. The other scenario, how much were they going to make off of us? $338,000. So in the long run, that refinancing of the house could potentially save us close to $200,000, more than $200,000. So, anyways, if you are going to buy a car or a house, I suggest you do that with somebody who knows what's going on to help you make good decisions, because it's very easy to get yourself in a situation where you're like, holy crap, this sucks, and you can't get out of it really. So just be, when you go to buy a car, what I always say is you go in, and if you're going to trade a vehicle in, the first thing you do is you say, here's my keys, go look at my car, tell me how much you're going to give me for my car. That's it. Don't go look at any cars, don't tell them what you want. Just go, give me my trade-in value on my car. And then when they come back, then you say, this is the car I want, give me your best price. And if they say, how much do you want to pay? You say, no, I want to know what the best price is on that vehicle. And then if you do it that way, you'll have to haggle with them, but that's the best way to do it, because then you'll have a price that they're going to give you for your car, you'll have the price for the car you want to buy, and then you start talking about payments. You don't let them drive everything with the payment. If they drive it with the payment, there's a way that you could drive a Ferrari, all right, or Lamborghini with that car payment. You could, but your loan might be 30 years. You know what I'm saying? So you never let the payment drive the purchase. You let the amount that you're paying for the car, and you let the amount of the trade-in drive everything. That make sense? Okay. All right. We're done. Back to the fun math. Yeah, so VA loans are different, right? So a VA loan for veterans, they get some advantages that they don't have to come to the table with the 20%, right? Because they're trying to help the veterans get started with a new home, right? So they don't necessarily require the 20%. But what the VA loan, I guess not the drawback, but the catch to that is that they're very strict about appraisals. So when they go and you're like, hey, I want to buy this house for $300,000, the VA is very strict. They'll go and look at the house and they'll say, it's only worth $200,000. And they're like, no, we don't agree that we should give you a loan for $300 because we only think it's worth $200. So they're very stringent about their appraisal values. That's what I've heard. But yeah, it's definitely an advantage because you don't have to come with 20%. Now, the drawback to the VA loan, in any loan where you don't have to put money down, is that you could wind up what's called upside down. Do y'all know what that means, to be upside down? Have y'all heard that term before on a loan, to be upside down? Okay, so let's say we buy that $15,000 car, right? Say we buy that $15,000 car. And we chose the cheapest payment possible, right? So maybe we're paying like $230 a month. And remember, this $230, not all of that goes to pay that off, right? Part of it goes to the bank's profit. So let's say after a year, you've been driving this car around, you've been making these payments. A year later, you will have paid, I don't know, roughly you would have paid about $1,400, roughly. After a year, you would have paid that much, right? So you would think that that's come down by $1,400. That's not the case. It's probably only come down by maybe like $600. Right, so after a year, this is more like, I don't know, $14,400. That's how much you still owe on the vehicle after a year. And then you go try and sell it, and people are saying, hey, look, we're only going to give you $12,000. That's the most you can get for your vehicle. $12,000, the most that you're going to be able to get. You are now upside down. You owe more money on a vehicle than it's worth. That's what's called being upside down. And you can be upside down on a house as well. You can owe more to the bank than the house is actually worth. So with VA loans, it's always a little dangerous because you never put money in up front. So you owe a lot on that house. And then if the value of the house drops for some reason, then now you're upside down. And you can't even sell it. You're stuck, right? Just like a vehicle. You'd be stuck with this car because why are you going to sell it for $12,000 and then still owe this bank money just to get out of that car? So that it's going to cost you another $2,400 just to get rid of your car. So you're like, shit, I'll just keep driving it, you know? So that's what it means to be upside down. You try and avoid this. And with vehicles, it's kind of tricky. Do y'all know the easiest way to avoid being upside down on a car? Leasing has its own catches because they put restrictions on mileage and things like that. I shouldn't even say this on camera, but I mean, you should try and avoid buying brand new cars. Because when you buy a brand new car, the first thing that happens when you drive off the lot is that it's no longer worth what you just bought it for. Like as soon as you sat in it and like dropped some chip crumbs somewhere, that's it. It's now not worth what it was 5 minutes ago because it's now a used vehicle. And so anytime you have new vehicles, you do a new vehicle purchase, you immediately have that hit of the drop in the value, so then there's that chance that you're going to be upside down. Now, people buy new cars every day, right? So it doesn't happen all the time, but it's something you have to be careful with, right? Be careful. If you can find a car that's, slightly used, then that's going to be a huge advantage to you. All right, now, as much as I say that, I actually bought a new vehicle because my most recent one was new because, like I said, it was a weird time. Used vehicles were hard to find. And so I traded in my truck and I got more than I bought it for, and then I was able to just turn that around, put it right into a car and not pay anything for that car. I got that car basically as a swap. So it made sense to do new. All right, we are done talking about that for now. I appreciate y'all wanting to talk about it. I mean, I know we're not going to be tested over this and half of you are falling asleep, but I think for some of you this is useful math, right? Useful ideas. So we are now going to move to our next type of function, all right? You know what, I should motivate it with this idea before I get to it. Let's say you have $5,000, right? You have $5,000 just burning a hole in your pocket, right? And you wish to invest it. That means put it somewhere where it's going to grow so that it doubles. You're going to try and see what you can do to double your money. You want to somehow see if there's a way to turn the $5,000 into $10,000, right? And let's say, yes?
Is this still exponential?
Yeah, this is still exponential, yes. So you've got $5,000. We want to see, how should we invest it so that we can double this money, turn it into $10,000? We hope to do this in, let's be realistic, in 8 years. We'd like to see if we can turn the $5,000 into $10,000, and we want to do it in a period of 8 years. What interest rate would we need? This is a different question than the question we just were doing at the beginning of class. We still have this formula. Okay, we still have the shampoo formula. This time, though, I'm giving you 5,000. What's the 5,000 in this problem? What is it here?
Principal, right?
That's the principal, right? That's the starting amount. Okay, I give you that, right? I want it to double, right? So I want it to turn into $10,000. Where does that go here? A. It's the amount I want at the end, right? If I want to double my money, that means I want $10,000, right? And that needs to be the amount at the end, right? So I want that to be 10,000. I put 5,000 in. How long am I putting the money in there? 8 years, that's my T, right? What do I not know? I don't know what the rate is, right? That I don't know, right? I don't know the interest rate. So let me plug everything in, okay? Let me plug everything in. I have 10,000, that's the left side of this, equals 5,000. And then E raised to the R times 8. And I want to know what R is, right? I want to know what R is. There's a problem. Where's R in this equation? Where's the R? Is it down on the bottom here with the numbers? No, the R is up here, right? The R is up in the exponent, up there up top. Okay, R is up there up top. And right now, in this class, and probably in most, unless you did algebra in high school or something, we do not have a way right now to get that R down and get it to be, like, get the R isolated by itself where we can solve for R. We don't have a technique for that. What I mean is this. If I give you this equation right now, could you solve for X? How would you solve for X here? Move the 1 over and then divide by 3, right? So you have a way of solving this, don't you? If you're trying to solve for X, you have a way of doing that because the X is just down there, you just move things around. If I give you something like this, there's another equation, right? That's called a quadratic equation. Could we solve this? Yeah, we could either try and factor it or we have the quadratic formula, right? So we could do this. Yes, we can solve for X. This equation, the variable we're trying to solve for, is not down on the bottom like here or like here. It's up in the exponent, which we've never dealt with before. And so we need a way of solving this, and right now we don't have it. And that's what the next idea is about, is how can we somehow go after that R and solve for it? All right? So this right here, this equation right here, we can't solve this. Yet, right? Yet. We are stuck. So this was just to motivate the idea. Right now, we're interested in saying, okay, how can we double our money in 8 years? In order to do that, I need to be able to figure out what interest rate would do that for me. I don't know how to solve for the interest rate. We're stuck. All right? We're going to back burner this, and now I'm going to introduce the new idea. I have to introduce a new function for you. First, we're going to talk about inverses. Inverses of functions. All right, I'm going to put a function up here for us. F of x. Let's start pretty simple. Let's go 3x. Let's see. That is a very basic function, right? All it does is it takes whatever you give it and it multiplies by 3, right? So visually, this function has an input and an output, right? If you take the number 1, it sends the number 1 over to 3, right? Sends the number 2 over to 6, sends the number 3 over to 9, right? That's what that function does. So f, this function, goes through this machine, comes back out over here, right? I'd like to talk about what's called the inverse the inverse of a function, what do you think the inverse of a function should do?
Be the opposite.
Do the opposite. It should basically undo what that function just did. So I'm wondering, is there another function that would go backwards? That would take everything that was here and work in reverse. It would go from here back to here. So it would take 3 back to 1. It would take 6 back to 2. And it would take 9 back to 3. Can you all think of what that function would have to be? What is that? X over 3, or 1/3 of x. So let's try it. If I did this function, f of x equals x over 3, let's plug these values in and see what happens to them. So if I plug 3 into that, what happens? I'm going to draw this function here. Right? If I plug in 3, where does it go? 3 divided by 3, 1. If I plug in 6, where does it go? 6 divided by 3, 2. Plug in 9, where does it go? Back to 3. Understand? That function undoes this function. And because that function undoes this function, we have a special name for that. That is called the inverse of this function, because it undoes this. So we have, not only does it have a special name, it has a special notation. I don't want to call it f of x because this is f of x, right? But that function is the inverse. So here's how I'm going to write it. I'm going to write, it's the inverse of that. So I put a -1 up here like that. And then I put the x over 3. See, by me writing f with a little -1 here, what that's telling you is that this function right here undoes that function. It's me telling you that. By putting that notation, all it does is tells you, hey, that function is the inverse of this one. Whatever that does, that one undoes it. Make sense? All right, so what if I just plug x into this? It would go into this function, right? It would come out as 3x, right? If I plug x in through this function, it would come out 3x. And then what if I send it back through the inverse? The inverse, what would the inverse do to this? Take it and, what does the inverse function do? It takes whatever you give it and divides by 3, right? So if you take this function, or sorry, you take that answer right there, what would happen if you take 3x and now divide it by 3? What would you get? X. So it takes it back to the x it came from. So x goes into f and becomes 3x. And then 3x goes into the inverse function, divides by 3, goes back to x. So when you put a function together with its inverse, it basically leaves everything unchanged. Okay, got it? Got it? You sure? That's the basic idea of an inverse. I think I might draw one more picture. Let me draw one more picture before I move on. If we start here, I'm going to draw it this way. We're going to look at it like a chain of events. If we have a function f takes something from here to here, and then we have the inverse function like that, then this is what we should expect. And don't think about the example we just had, okay? Forget the 3x and all that. This is just generally speaking. If I tell you I have a function and then its inverse, let's say I plug in 2 and 2 goes to 7. Let's just say. Can you all tell me where 7 now goes if I send that 7 through the inverse? Back to 2, right? So 2 goes in, somehow becomes 7, and then now that 7 should go back to 2, right? If I plug in -1, and let's say I tell you that that turns into 5, where should 5 go if I send it through the inverse? Back to 1, or back to -1, sorry, like that, right? So if I plug in x, right, and it comes out here it'll be whatever the function is at x, right? Whatever it is. I don't know what that value is. It's whatever the function says to do. But where should this go? Back to x, right? So when you put together a function and its inverse, they basically kill each other off, right? Like start out at x, go through f, whatever happens, happens, go through the inverse, goes back to x. This also works the other direction. If I start with 2 and I go through the inverse first, it comes out as 7 and then goes through the function, it'll come back out as 2. So the direction of these works in both ways. Doesn't matter where your thing starts. As long as it goes through both the function and its inverse in any order, it comes out unchanged. All right, hopefully you understand that idea because now we're going to talk about logarithmic functions. Let me start by saying this. What type of function is this? What type of function is that? Exponential, right? That's what we've been studying before this, right? We were studying exponential functions. 2 to the x, right? Folding the paper, the rectangles, tearing that paper in half, right? The bacteria. Then there's the 2 special ones, e to the x and 10 to the x, right? So we studied this thing called an exponential function, right? Let's look at a specific example. I have not told you what a logarithmic function is yet. Okay? Still talking about this right now. So let me give you specific examples, one that we're familiar with. F of x equals 2 to the x. Let's see, what does that function do if I plug in 1? It's 2 to the 1, right, which is just 2. What if I plug in 2? Plug 2 in right there. 2 to the second is 4. What if I plug in 3? 2 to the 3 is 8, right? Be careful, not 6, right? Because we're raising it to a power. Y'all good with that? I could keep going, right? I'm not going to. My question to you is this now. Does this function have an inverse? Can you think of a function right now that would send 2 back to 1, 4 back to 2, and 8 back to 3? So I'm asking you, is there a function that would be the inverse of this? Maybe it's a root? I don't know. Does square root work? What's the square root of 2? Not 1. Square root of 4 is 2. That works, but it doesn't work for all these. Any other ideas? Are you having trouble finding one?
I don't know, Doc.
Yeah, you're having trouble finding one?
I'm thinking you divide the x by something, or the x by...
Well, you're looking at this, right?
Yeah.
You're looking at this, you're saying, how do I turn that into a 1? You could divide it by 2, right?
Yeah.
If I divide that by 2, I get 1, it works. If I divide that by 2, I get 2, it works, right? If I divide that by 2, I get 4, that doesn't work. It needs to work all the time, right? So like we're struggling. Do y'all see we're struggling to find something that undoes this function, right? What is it? And as much as we look, we're not going to find it, okay? We're not, because we haven't studied them yet. I'm about to tell you what they are. I'm about to tell you what functions undo exponential functions. The inverse of an exponential function is something you've never seen, well, maybe in algebra or something in high school or whatever. The inverse of this function right here is what we call a logarithmic function. They're called logarithmic functions. And they're weird because they're not algebraic. It's not like you divide by 2 or you square something or you take a square root. It's a function that looks different than anything you've ever seen before. So this is where students start to like lose grasp of things because it's strange and unusual. So what I want you to take from this little note up here is this. We've studied exponential functions. We know what they do to numbers. We're trying to see if we can find a function that can come back and undo this. And I'm telling you that there's nothing out there that it has to be this thing called a logarithmic function, which I haven't even defined for you yet. So now I'd like to try and define what a logarithmic function is, and then hopefully you'll see how this all works out. So to define a logarithmic function, I first will define what is called a logarithm. A logarithm. I need to define this thing called a logarithm. Once I define what a logarithm is, then I will define what a logarithmic function is. All right, we're about to play a game. You ready? We only have 10 minutes. We're about to play a game. Look at that equation. 2 to the x is 8. Can you tell me what x is? 3. Just by looking, right? You're looking and saying, okay, 2 to what power is 8, right? Let me say it again. This is really saying 2 to what power is 8? This is really saying 2 to what power is 8, right? 2 to what power is 8? That's what that is actually asking you to do, right? Figure that out. Which we can just think and say it's 3, right? 2 times 2 times 2. So the answer is 3. So x is 3. What I'm going to do, this is so weird when students are trying to learn logarithms because it's so strange. What I'd like to do is I'd like to find another way of me stating this sentence without actually me writing it out in words. I wanted to use some like new notation that means that, but that you will understand. Every time I write on the board, you'll understand it's this question. 2 to what power is 8? That's a question mark, right? So here's how I'm going to write this. Instead of writing out, here's what I'm going to write. I'm going to write log, L-O-G. I'm going to subscript it with a 2, and then I'm going to put the number 8 right there. Now, why do we use this notation? I don't know. I wasn't there when they made up this notation, all right? This is what humans